So just one question, sir. In though it's a graded assignment question, so I am not asking for the solution. I'm just
Okay.
asking like there is a question where it is asking us what is the explained variance.
Okay.
Okay, so is it same as any variance of the predicted value or something like that?
Explained variance. It is you are saying that is it same like other variants? No, no, no. It is not like that. Okay. You have many articles on this. Okay, you can read that. I think one practice question, assignment question is also based on this. I mean, just that's like how you will use that explained variance. Okay.
No, so explain variance wasn't covered in week 3 actually, but there is a question in graded assignment on explain variance.
Okay, is it? So I haven't seen that, so I can't comment on that. So you want to what you want? I mean, that explained variance or what?
So what exactly is that explain variance and which sklearn API does it come into?
Explained variance is like R square. Have you heard about that term? I mean,
Yeah, R
have
square
you,
square we know, sir. That was
yeah.
taught.
So yeah, so it is something like explained variance is nothing but this. It is measure the discrepancy between a model and actual data. Okay. So I would say yeah. Hello.
So does it fall into the metrics, sklearn.metrics library, sir?
It's actually R square only. We call
Okay.
that explained variance. Okay.
Okay.
So it is not same like the scoring function we do in linear regression.
So yeah, scoring function only.
Like
No? Yeah.
like
So,
in case of linear regression, sometimes we do know like we find the score and find the mean standard deviation. In that way, if I find that variance, so will it give us the same answer or it will give us the
no. I'll show you the formula. Actually, I don't have currently all those things. Okay, let me share the screen. Okay. So it's like it's formula something 1 minus u by v. Okay. So where your v is a baseline model and it's like how much it is deviating from your baseline model. It is something like that. Okay. Where the model created by you is how much it is deviating from the baseline model. It is something like that. The performance of your model is getting compared with the baseline model. It is something like that.
okay. So okay. So we need
So
to
that the kind of
find the baseline model. I mean prediction of
it's a,
baseline model and then
yeah.
compare with it.
Yeah, it is like just a formula. In MIT, you will knowing that how it works and all those things. But in MLP, it's just like a formula. You have to use that R square formula. Okay. I mean, you have to use that R square value, and that yeah, it is something like formula is something like 1 minus u by v. You also call it as a coefficient of the determination. Okay.
Okay.
Okay. So let me see this. Okay. So yeah. Hello everyone. I welcome you all to the week 4 activity and practice session. Okay, before starting these questions, I know the activity questions are quite easy in week 4. Okay, so mostly based on that APIs and all. So what I would expect, like I'll ask few other questions also in the meantime. Okay, so just to check, like so first question I would ask is like how much you would like how is your experience till now in MLP? Like how comfortable you are feeling in MLP? Just rate based on 1 to 10. Okay, you can message I can message in the chat box. That is also fine for me. Okay.
Sorry, sir. What was your question?
So I am saying that how is your experience in MLP till now? Okay. So how much comfortable you are feeling in MLP till now? Okay. So you can rate your expertise or something. I would say how much you comfortable you are in MLP till now, based on 1 to 10. 1 is the like absolutely you didn't understood anything, and I would say like 10 is you understood everything till now. Okay, so just I want to understand like how much you are lagging and all. Very tough 9. Okay, toughness 9, but 9 after. Okay, Salis is on code level. Okay. Yeah, Yogendra Singh and all. Okay. So yeah, I would say here. So whoever has understood the good thing, I would say I would ask you questions. Okay. Prasant 6.5. 0.5. Yeah. Okay. So this white screen is visible, or which screen is visible currently?
Yes, sir. Yeah.
Yeah.
Yes.
Okay. Yeah. Okay. Okay. So this chat box is not visible, no? I mean, in the screen.
No, sir.
Okay, then it's fine. Let me mute some. Hey, who is speaking? Just mute yourself. Yeah. Screen half visible. Is it still it is half visible or what? Okay, yeah, thanks. Okay, so yeah, I have a few questions for you guys. Okay, so what do you think? I mean, where you are like too much code or what? Yeah, hello. So yeah, one of you can unmute yourself and yet say.
So there is too much of content every week. I mean, week 2, week 3 were loaded with content. So that is a problem actually.
Yeah, that I agree. Okay, and for that we have a proper solution. I mean, yeah, I would say yeah, plus so much of the content. Yeah, that's true. I agree because everything you are learning just now only. So once you will get comfortable, I mean the same thing you have to use in other weeks also. Like it's just that algorithm changes. In MLT you would have some new concept, but in MLP more or less the same thing will be there. Like just here you use a linear regression, then in logistic regression you will use that term logistic regression. That's it. Okay. So these are the codes, like a good amount of code. So that's why unable to maintain the pace. Okay, just think it like whatever you learned till now, no? Like most of the you have already covered the 70 to 80% of the content. I would say something like that. 70 to 80% of the new things in MLP, I would say, because the rest other contents are just like a few extra lines of code you have to add, and few extra lines of code you will modify in this content, and yeah, you are ready to crack the other weeks also. Okay. So yeah, that's why I asked you these questions, because I have seen in the last time also, like people were really worried around week 4. So because the same complaint, like yeah, we have a lot of content, yeah, a lot of new things, because whoever is uh, studying it for the first time, no, like whoever using this sklearn library for the first time, they will definitely feel uncomfortable. Okay, sir, where can you find quiz one previous year? See, I can't say that, but yeah, there are discourse, there are people, like yeah, whoever has uh, studied these things, yeah, in last term, they would have shared with you all something like that. Okay.
So what kind of questions can we? Because most of the graded assignment, practice assignment questions are about a data set and we have to work on it. So I was wondering what kind of questions will be there in the quiz, because
Yeah.
there we can't work on a data set.
Yeah, in quiz mostly there will be like questions, something like the, yeah, there would be some snippet, code snippet, and they will ask like what would be the output, something like yeah, there would be some parameters, like let's say like there is some parameter and which is set wrongly. Okay, so you have to say that whether it will throw an error or not, something like that. Mostly question will be like you have some code snippet and you have to answer what would be the output. Okay, something like that. And there would be some, in that only they will do the some iteration or some changes, something like that. So the thinking like you, if you are able to understand what particular code is doing, so then yeah, you will be able to handle this quiz. Okay, and then in
Okay,
OP
sir.
you have to yeah, write all the
And
codes and all. Yeah.
And will there be a mock for this quiz one, sir? Because
Yeah.
sometimes you don't give us a mock.
Yeah, I think usually for the quiz, first quiz we give the mocks.
Okay.
That
okay.
is what I am assuming. Okay.
Because
So
that probably we'll get a clue on what are the type of questions.
yeah, that's true. I mean, for the first quiz we should give. Okay, and I'm also expecting, yeah, for first quiz they will give.
Okay, sir. Thank you.
Yeah, actually I don't remember like last time we had given or not. So yeah, that's why I'm saying like this. But yeah, usually we give the for the first. But yeah, I'm sure like in the last term for second quiz we didn't give. But yeah, for first term we gave for OPE also, mock OPE we have given, so that yeah, definitely those will give you the idea. Okay.
Yes, sir. Thank you.
Yeah. Okay. So yeah, in the meantime, yeah, let's discuss few activity question, and yeah, I'll try to involve you guys. Okay, that's it. So because it's not good thing like I'll speak and you guys just listen. So yeah, that is what I trying to do. Nothing else. Okay. So yeah, let me just remind this. Yeah. Okay. So which of the following API will generate a new feature matrix? Okay, consisting of all polynomial combination of the features with degree less than or equal to the specified degree. So I think you guys knows it's just about that type API, how it is mentioned in the skill API. It's the first one. Okay. So yeah, this kind of thing usually you should not remember, but here for sake of completion, I mean, you may get one or two questions like that. So yeah, I would say yeah. Usually we try to avoid this type of questions, but yeah, I would say just remember these things also. Not all, but yeah, important one. I mean the popular one, I would say. You may get questions related to this one in yeah, in quiz one. Okay, because they may ask like something the transform features. Okay, and yeah, obviously it will throw the error. So something like that question you may get. Okay. So the second question says what will following code implement? Okay, from sklearn. So what in the first three line is code is just importing all the statements, and then what we have done, like we have first kept the polynomial transform of degree 3, and then we applied linear regression. Okay, so yeah, this is the thing we did, like it will apply the polynomial transformation of degree 3 on feature matrix X, and then we'll learn the linear regression model. Okay, so yeah, that's what we did here. So yeah, so in the third question, it is asking like what will be the transformed feature of x1, x2 after execution of following code. Okay. So what do you think? I mean, here, what will be the answer? I would ask you guys only. That would be what I think. Yeah, someone just speak. It's not an issue. Or maybe you can chat also. Okay. It's completely fine with me. Fourth one. Okay. Yeah, that's one. That's the correct one. Yeah. Interaction only equals true. No. So yeah, some other person just answer. Okay, one answer, third one. Okay. Charles is saying the third one. Yeah, fourth one. Okay. Okay, anyone else? Just try to engage. That is what I'm expecting you guys. Okay. So yeah, 3-4 answers I got. Okay. So, or if you don't understand the, still just a tukka. Okay. I'm also fine with that, because when you will do the mistake, no, then you will remember properly. Like, yeah, that is like when I tried tukka, and yeah, that is the mistake I did. Okay. Something like that. So that's why I'm asking. See, can anyone explain like what polynomial features does? Hello. Anyone? Sir. I will start taking names randomly. Okay. Yeah, hello. It will convert linear features into non-linear. Okay, that's the correct one. Yeah, Yogendra Singh. Okay. Anyone else who wants to add anything plus or minus, something like that? Anyone? Okay, I'll see. Okay. So the thing is, what happens, like a polynomial features just transform it in the higher order. Okay, something. So, but here, what is it will just give you all the combinations. Okay, so first you start with the one x1 x2, then x1 x2 x1 square x2 square. But yeah, here we have mentioned the term interaction only equals true. Okay, I mean we have said this parameter equals true. So what this parameter does is, like when we set this true, then it just avoids this higher order. So the correct answer would be the third one. So we have x1 square and x2 square won't be there. Okay. but by default it is set to the false. Okay, so if it is the default condition or we set it as a false, then yeah, fourth option would be the correct one. Okay, so here the third is the correct one. Okay, so yeah, let's move to the next one. Okay, I'll repeat it. What I'm saying is there is a parameter in polynomial features named interaction only. When we set it true, no, then it avoids the higher order terms like x1 square, x2 square. We don't, we just neglect those terms, or you can say that we don't consider that. Okay. I mean, okay. I just got locked out. Okay, let me relog in. Okay. X1, X2 will be higher term only. Yeah, but it doesn't avoid that. I mean, how it works is like it works the higher order term like x1 square, x2 square. The higher order term of the with that term only. I mean, x1 square, x2 square, something like that. Okay. So yeah, it doesn't. That's how this API is made, I would say. Yeah, that's true. Yeah, x1 x1 into x2 is also second order term. I agree. Let me relog in. Yeah. So in the meantime, can someone says like what is hyperparameter? I'll try to revise the chapter. Okay. Hello.
Hello.
Yeah. What is hyperparameter?
Hyperparameter are the parameters input by the user.
So parameter inputs by user. So all the parameters are inputted by you only state no? All the parameters.
So if we want to improve the degree, we need to explicitly mention the degree to be like 3, 4, so on. So degree becomes hyperparameter. This is input by the user.
Okay. Degree is the input by the user. That's true. Yeah. And yeah, something more you want to add? Yeah, something.
Number of iterations we want to, I mean, where we want to end up.
Yeah, that is also a good one. Anyone
And
else?
weight
Yeah,
vectors, initial weight vectors.
Initial weight vectors. Yeah, no, that's not enough to do. Like weight vectors, number of degree. These things are true, but weight vector is not a hyperparameter. So weight vectors you don't set, no. Yeah, your model learns, no. Your model learns from themselves. So you don't set that weight vectors.
Okay.
Yeah.
Okay.
So yeah, one good question I would ask, yeah, like, can you mention any hyperparameter in linear regression? That normal equation we have, no? In that, any hyperparameters? Hyperparameter in linear regression. That is my question. Okay.
So
The learning rate is a hyperparameter.
Directly calculate the model, but model needs to reach to a satisfactory level of performance.
So what you said, just repeat it.
So hyperparameters are those parameters that are required by the model in order to reach to a satisfactory level. These parameters are not itself calculated by the model.
Yeah, that is also correct. Yeah. Yeah, I am satisfied with that answer also. Okay, yeah. So yeah, coming to the current question. So I asked like, can you name some hyperparameter in linear regression model? Whatever you told, no, like learning that is in SGD regression. Okay. Yeah, that is also correct. Means we use that in gradient descent. We use SGD regressor uses the gradient descent method, and there we use that learning rate and all. Okay. So reason also, yeah, this is not your proper linear regression. Okay, I mean, what I'm saying is like I'm asking about that in SGD, not in SGD or not in RIS or not in LASSO. We have hyperparameters. Okay, but I am asking about first. I'm asking about linear regression. You use the term no linear regression. I mean, let me.
Yes, so it's a normal equation, right?
Yeah. That's a normal equation. That is what I'm asking. In that one,
normal equation, I don't think there are any hyperparameters.
that's perfectly correct. Yeah, that is what I was saying. There are no hyperparameters in normal linear regression equation. Okay. So yeah. So next question, since you guys mentioned, like, yeah, you can mention some hyperparameter name in SGD. Okay. In SGD, just yeah, mention some hyperparameters. One was the learning rate. That's true. Okay. Any other hyperparameters? And yeah, now I'm open for region loss also. You can mention the hyperparameters which is involved in the region loss also. Okay. Hello. Anyone?
Sir, TOL,
Yeah. What?
tolerance.
Tolerance. Okay. Any other? Your alpha is a hyperparameter. You said this value, no? Your
Yeah.
penalty, yeah, in SGD regressor, penalty is also hyperparameter. You can set L1 or L2, something like that. Okay. For SGD regressor, it is there. And for RAISE or LASSO, you have alpha is a hyperparameter. Okay. So these value you set. Okay. Your model doesn't learn by itself. Okay. And you can think a hyperparameter just like a knob of your model. Okay. Which you can regulate. Okay. To improve the performance of your model. Okay.
Sir, here one question.
Yeah.
So n underscore iter underscore no underscore change, is it a hyperparameter or not?
Which one? Just repeat that. Number of iteration and iter. That is what you are asking.
No, n underscore iter underscore no underscore change is equal to like 5 or 7.
I am actually not getting your point. Just can you repeat? Or
So
maybe
n underscore iter underscore no underscore change is one of the parameter inside SGD regressor.
okay. Yeah. If you are able to just set different values for that, no, then that's your hyperparameter. Okay. So in SGD regressor is like the best part of SGD regressor is like it's completely modifiable. Okay. You can modify it properly. Completely you can modify it. Okay. So yeah. I think
Sir, in
yeah.
this, can you help us understand how that elastic net works? Like, how does both the regressors work together?
I mean, there is a formula for elastic net. Okay. So
Yeah.
you know that formula elastic net, it's just I would say that it's just a combination of both the let me just wait. Okay.
You're not audible, sir.
Yeah, hello. Am I audible now?
Yeah, yes, sir.
So it's just a convex combination of L12 and L1. It's just like 1 minus L1. Let's say L1 equal to L1 ratio equal to 0.3. So obviously L2 ratio would be 0.7. Okay. So your elastic net would be something like 1 minus L1 ratio. Okay. Okay. 0.3. Okay. Into.
Sir, are you writing somewhere because it's not visible?
Yeah, I'm writing. Is it not visible?
No, sir.
Okay, let me see. So yeah, just a minute.
Activity questions are now visible, sir.
Yeah. Sorry.
We can see only activity question.
Okay.
Yeah. Now it's visible.
But yeah, that's perfect. Yeah, I wanted to. I had written some other at some other place, but yeah, I think let me try that also. So I'm good to. Yeah, is actually the thing is I didn't bring my laptop here. Okay, so I'm using some other person's laptop. Okay, there it is. This one is a screen. Yeah. Okay, whatever about, yeah, is it visible now? Hello.
So the activity question is visible.
Okay, that's it. I'll just drop all. I'll set the complete screen. Okay. Yeah. That's correct. Is it visible now? Hello.
Your writing screen is not yet visible.
Which one is visible currently?
The activity questions.
Not sure. I opened this one. Let's see. It is happening. I'm saying my computer screen. So what about now?
Yes, your entire screen is visible.
Yeah. So 1 minus point. It's just like a it's a, for elastic nets. It's a formula. Okay. It's just like 1 minus. It's just here you have to put that L1 ratio. It's
We are still not able to see the Jupyter notebook.
Jupyter notebook. Are you saying?
No, no.
I mean,
We can see your desktop.
All the apps are
okay.
main screen.
Let's Jupyter. Don't know why I'm struggling. Okay, let me see here. What can I do? Share screen. So is it visible now? Blank screen? Hello?
Whiteboard
Yes,
is.
sir, yes.
Yeah, okay, I typed okay here. Actually, I was writing at some other place. I think it is so it's elastic net formula is something like 1 minus L1 ratio. Okay. So bad writing. I mean L2 plus L1 ratio it is. Okay. Into L1. So let's say, so you know, no, here L1 is your lasso, okay, and L2 is your race. You know, no? Hello.
Yes, sir.
Yeah.
Yeah.
So what happens is like in the formula we mention like either we mention L1 ratio or we mention L2 ratio. Okay. So let's say in the formula we are given is L1 ratio. Okay. So for L1 ratio, the value is something, let's say 0.3. So what happens here is it just converts like 1 minus L1 ratio. So it gets converted into 0.7 into L2 plus L1 ratio is 0.3 into L1. Okay. So now it is your formula. I mean, whatever value you will get from the reason, you will multiply it with 0.7, and whatever value you will get as a lasso regression, that you will multiply with 0.3. So you are giving the 0.3 weightage to the lasso and 0.7 weightage to the regression. Okay, in this formula, in this elastic.
So,
okay.
So basically, sir, all the coefficients will be multiplied with these factors, right?
Yeah.
Okay, and it will happen one after the other.
Yeah. I mean, yeah, you are whatever the value for lasso you are getting, you are just combining combining both lasso and ridge with ratio of 0.7, 0.3. Maybe you can put you can give equal weightage to both, so you can use that 0.5, 0.5. You can say L1 ratio or L2 ratio 0.5. Okay, it's just a normal.
Okay. Yeah, got it, sir. Thank you.
So, see, So let's come to these questions. Okay, again then I'll ask the question later. Okay, so which of the following are correct ways to perform regression with the regression rate of 0.2? So which one do you think is the correct one?
First and last.
First and last. So yeah, last term, since here penalty equals L2, so yeah, this one is correct. And since the API for res regression is res, not res regression. Okay, so yeah, both are correct. Okay, so here the mistake is like we are using the wrong API. Here the mistake is we are using penalty equals L1, so which is lasso regression. So yeah, that is the mistake here. And let's move to the which penalty is used to perform both lasso and regression. Polynomial regression using SG division. So yeah, combination is elastic. Okay. So which of the following keyword parameter is used to set regression type? So which one do you think is? Which of the following parameter? Just think.
Alpha.
It's just
Penalty.
yeah, penalty. Here we have used no here in this term only where we have used penalty to set the regression type. I mean L2 here we have set it. So yeah, it is regression. On here we have used set L1. So which that it means that's a lasso. Okay. So yeah, that's the correct one. Penalty. Okay. So SGT ratio penalty equals elastic need L1 ratio equals 0.3. So what would be the L2 ratio? So yeah, answer someone.
0.7.
0.7. Yeah, that, because always the sum of both will be 1. L1 ratio plus L2 ratio equals it will be 1. Okay. So anyone has any doubt till now? Okay, let's move to the second part of this. So yeah, to the question 4.3. Which of the following statements are correct about the hyperparameter? Okay, so yeah, first term is this one. Hyperparameter is the parameter whose value is used to control the learning process. Yeah, it seems correct. Second term is saying parameters that are directly learned within estimators. No, it is not learned within estimators. We provide that. Okay, so this second one is definitely wrong. Anyone has any doubt? This one or here? Third one says yeah, parameters that are not directly learned in the estimators. Yeah, so yeah, second and third one is just opposite one. Okay, so yeah, third one is here correct. I think most of you has already said this one. Linear regression weight vector is an example of hyperparameter. No, it is not, because as we discussed earlier, weight vector is learned by the model. I mean, at the end we get the weight vector after training the model. So what are the two hyperparameters search approaches? So which one? Obviously, this is also related to API only. I mean, yeah, if you know the exact name, it depends on that. Grid search CV and randomized search CV. So yeah, that's the correct one. Okay, and the third one also is the similar only. I would say yeah, use it's just the name of API, nothing else. I mean, just spelling mistakes. Okay, so what do you? So my question would be like, what it does like estimator dot get params. Okay, what does it will give output? Can anyone say? Yeah, hello. Is anyone awake or everyone's left? Yeah, hello.
Yes, sir. Which question, sir?
Yeah, in third one, I'm asking like which of the following APIs used to find the names and current value for? Yeah, actually in the question only it is written, so I did write the question.
Last option.
Yeah.
Estimate.
Yeah, okay. So which of the following options is correct about grid search CV? Which one you think? I mean, can anyone explain like what is the difference between grid search CV and random search CV? Just someone, just explain. Just try to explain. Okay. So that yeah, whenever you will miss something, I will add that one, and yeah, you will be able to remember it properly and in better manner, I would say.
Sir, in grid search CV, we are going to provide range of values, parameter values, and based on those values, it will give you the best value.
Okay.
In randomized search CV, it gives a distribution of values.
Okay. So I would say, yeah. Have you got any difference? I mean, from your definition, I didn't get any difference. So
Sir,
yeah,
does it give a distribution, or do we give it a distribution that it should be uniform or something like that? I mean, I don't know.
we give it. We give set the
We
distribution
give
type.
we mentioned this the distribution, right,
Distribution
sir?
type. Yeah. So anyone else want to try? Just try. Okay. First thing, I mean, you are partially correct. I mean, whatever you told, that is correct. But yeah, I need to add, means the basic main difference is not that. Okay. So why, how that will be useful? I would like to ask that. Okay. Anyone else want to try? Just try. Basically, I want to know like where you are lagging. So then only I will be able to explain that now. Okay. Anyone? Anyone just try? Anyone?
In grid, it is that we give values, and those values only the model learns on. And in the other one, randomized, it's like a distribution, and with those distribution, the model learns.
Okay, so yeah, more or less you guys are in the correct path, but exactly like where it will be useful, that I explaining. Okay, so the thing is, let me again share the screen. Is
Sir,
it? Yeah.
I think the grid search CV takes a lot of time because it searches in the all possible combination of hyperparameters, and random search is searches randomly any number of hyperparameters, so it will be less time consuming.
Yeah, exactly. I mean, yeah, 99% correct. Okay, I would say 99%. Yeah, up to what I was expecting. Okay, so the thing is, I'll just try to show. So let's say you have, let's say you in SGD regressor, screen is visible, no? That blank screen.
Yes.
Hello. Okay, let's see in SGD regressor, you have two terms. Okay. Yeah, in SGD regressor, you have two terms. Okay. You have one parameter which is penalty. Okay. You are setting it as L1, comma L2. Okay. And you have let's say alpha values. Okay. Alpha values. Okay. And yeah, you can take it from like 0.1, 0.2, something like that. I mean, the whole 0.1 to 0.2, like something till 0.9. Okay. So what I would say, what grid search will do? No, grid search will take all combinations. I mean, first it will take it will train. I mean, let's see, like two pieces are here, and here let's say we have 9. It is no. So okay, just convert it. So here we have 10 alpha values. Okay, 10 alpha values and 2 penalty. So what it will do? It will run 20 times. Okay, first it will take L1 plus alpha equals, I'm showing it as A. Okay, L1 plus A equals 0.1. Okay, so actually I'm not using the writing book, that's why the writing is too bad. Okay, so now again again it will take L1 plus alpha value equals 0.2, and like that it will take all alpha L1 all L1 with all alpha value. Okay, L1 plus, similarly L1 plus 0.9, L1 plus 1.0. Okay, and it will calculate the score. Okay, and then again it will go with L2 plus 0.1 alpha value, L2 plus 0.2 alpha value, L3 plus 0.3 alpha value. Then similarly L2, sorry, it's L2. Okay, L2 plus 1.0 alpha values. Okay, and again it will calculate all the scores. So what will happen is now it will result, it will give you the final answer, like what is the best score value among all. Okay, so I mean 2 here, 10 here, so I mean it is running 20 times. Yeah, obviously you have options like you can run all the I mean all the model parallelly, but still, yeah, I mean it is training 20 models. Okay, it is something like that. So it is running 20 models and the best score will be your answer. So it works like that. I mean, it takes all the combinations. Let's say if you would had any other hyperparameter value also, no, it would have used that one also if we would had any other parameters. Okay, so yeah, it would have tried all the combinations. So obviously it's a time consuming. So but in your randomized search, what happens? No, like we set the distribution type. I mean, let's say we are setting normalized distribution. So, and we are setting the value maximum and minimum value. Like let's say maximum value is 1 and minimum value is 1 and maximum value is 1000. Okay. So what it will do, in randomized search, it will do the randomize based on that distribution. It will take the values from this one. Okay. And it depends on us only, like how much value we want to take. It will distribution, it will take value according to that distribution formula. But yeah, how many value we want to take, like I mean how many combination we want, that we can, it depends on us. I mean here we it is not on us, like how many combinations we want. I mean we have to it will train 20 models. Okay, but in randomized search we had options. I mean I want to train just 10 models. Okay, it is just that one new thing happens in randomized search, that we can set, I mean which type of I would say, like which based on what distribution we will take values for alpha. So did you guys got my point, or I was not able to explain something like that, or you need some more examples, something like that, you can say.
Sir, can we have an example of alpha value for randomized CV?
Yeah, for randomized CV, I would say that yeah, it's better to see the code only. The thing is, what happens is, let's see. Okay, I'll try to explain here only. So what happens in randomized search? No, randomized search. Let's say I have to take value between 100. We said that minimum and maximum. You just I would suggest you to search that randomized search sklearn. Okay, you will get the like what is the pattern of this randomized search. I mean how we set all the parameters. Okay, so what happens, like you have to set the minimum value, you have to set the maximum value, and then you have to set like based on which distribution you want to select value between these two. Okay, so let's say we are setting value normalized. Okay, yeah, we are setting normal distribution. So as you know, in normal distribution, most of the value will be between 40 to 60. You know, no? So yeah, it will try to select the maximum value, and we are setting here like we want 5 values, just 5 values. Okay, so it will take 5 values randomly. I mean, yeah, based on this distribution formula only. Okay, that you don't have to worry. And how you will use this one? I mean, this you can say this. What was the name? I just grid search and randomized search. When you have lesser number of combinations. Okay, let's say here we had L1, L2, and alpha value is between. Okay, alpha value is between. Someone please mute. So yeah, muted. Okay, so yeah, in the I would say in this one grid search, when you have lesser number of values. Okay, here we have to train the 20 models only. Let's say here if we would had alpha values from 0.1 to 100. Okay. Are you getting my point? I mean, then how many combinations would be there here in SDDX? Then it will take a lot of time. So what we will do now in those cases, we will use that randomized search, and randomly we will select a few values among these values to train our model. Okay. So it will save your time and obviously your cost also.
But when it picks up randomly, how do we know that it is the best one?
Yeah, that's a good question. I would say, yeah, this is the main issue with the randomized search. But at certain point, no, like say in medical sector, you want to try each and every values because you want the best one. You don't worry about the cost and all. Okay, so in those cases, obviously, obviously SJD regressor is better because this one is trying each and every combination. Okay, but in randomized search, it is not trying each and every combination. It is searching randomly, but yeah, based on that distribution, like which you have answered. Okay.
So basically, it's a weighing of between time and how much accuracy you want.
Yeah, exactly the same thing. Okay. So,
but sir, here we are giving additional parameters, that distribution.
Yeah, that is. So what you want? Yeah.
So if we are having some kind of bias in the giving in that distribution, so or it will always be normal.
No. You can set any type of distribution. No. Any type of distribution. Like I want to take value between 1 to 100. Okay. So I am setting here as a normal distribution. So what normal distribution says, like it would be like a bell curve. No, 1 is there, 100 is there. So it will be something like that. I mean, just I draw the wrong one. Let's say this one is 50. Okay. So yeah, 50% value would be this side, 50% value will be this side, and most of the value which will take, no, it will be between 40 to 60, something like that. Yeah, no. So yeah, obviously, there are very rare chances. I mean, if I'm taking 10 values, no, then there are high chances like most of the values from among those 10 values, most of the values belongs to this portion only. Most of the values belongs to 40 to 60 only. There would be very less value closer to 1 and closer to 100. Okay, so it is like that.
So it is safe to assume the normal distribution only, because according to CLT, ultimately all the distribution.
Usually use normal distribution.
Okay.
Yeah, and also it depends on the situation. So that's why we have options. It is like nothing. Yeah. It is never like, yeah, this is the best one, that is the best one. In whole ML, just think like that only. You have to try. Maybe this particular thing suits your model, that particular thing will suit different model. It is like that. No one knows like which one will set which model. Okay, you have to try and see, and yeah, based on your data set, you have to think about that. Okay,
sir.
Yeah.
So the alpha value you took from 0.1 to 0.1, right? So
yeah,
how do we know that these are the values that you need to give in the first place to start with?
We don't know. You can set any alpha values. We don't know. It's you like who have to decide. As I told you, this is the knob. Like in earlier days, have you seen that national TV? Like we used to had antenna and we used to knob. I mean, we used to turn the knob to set the exact angle so that we get the proper pictures. Na?
Yes, sir.
I mean, yeah. So it is like that only. I mean, you have to set. No one knows like which one will give you the best value. Maybe I set here 0.9 and you got the value as 0.9. So, but there can be case like 0.99 will give you the much better value, much better accuracy. There can be a case. So yeah, no one knows that. Okay, it depends like how much accuracy you want and all those things, and how much critical your model is also. I mean, if you are working in the medical sector and all, so obviously you have to see the. I mean, yeah, you have to see the manual details also. It is like that. Okay, so yeah, this one is done. So yeah, in that one, this is. So yeah, this question is completely related to that one. I mean, data set. You are simply loading the data set.
Sir,
yeah, please.
Sir, 4.3 last question, sir.
4.3 last question. Okay. Let me see. Oh, in the last second. Yeah, some parameter settings may result in a failure to fit one or more folds of the data. Which keyword you use to avoid the same failure? Okay, so yeah, error score is equal to 0. So what you want? I mean, so what it says? No, there can be some comments which is not possible. I mean, we are providing, let's say, L1 ratio, L2 ratio we have provided, and there can be a case which combination is practically not possible. I mean, uh, just think about any combination which is not possible. So what will happen? No, if we won't set error is equal to 0, the model will give error and yeah, model will stop working. Okay, the code will stop running. So to avoid that, we set error score equal to 0. Okay. So it's just like it will skip that part. It will skip that combinations. It is like that. Okay. So did you got or?
Sir, what does it mean failure to fit a fold?
I mean, that is what I'm saying. What I said, no, okay, there can be a combination. You are, let's say, L1 ratio, L2 ratio you had, no. I mean, yeah, let's say penalty is L1, L2, and alpha value is 0.1, 0.2, 0.3, 0.5, 0.6. Okay. There can be a case, something like in one set, when you are taking L1, I mean, yeah, penalty equals L1 and alpha equal to 0.5. Obviously, it is not, it will give you, it won't give you the error, but there can be any combination, something, let's say, we have combination where penalty equals L1 and alpha value is 0.5. So it will give you the error. I mean, practically just think like, no, I am dividing 1 by 0. Somewhere your model gives you something like that. Okay, which is not practically possible. I mean, obviously it won't run. No, there your code will throw an error. So there can be some cases. Okay, usually we don't see that those cases, but there can be any combination where your model will give you the error. So what happens
So
usually,
does it mean combinations which go beyond one? Like if I take a combination of L1 as 0.5 and L2 as 0.6, that doesn't work. Is that what it means basically?
Yeah, but yeah, that yeah, something like that you can say. But the here is like we don't set the no. If we can either we can set L1 ratio or we can set L2 ratio.
Yeah.
Or whatever you said, that is also correct. I mean, if you are setting any kind of combination where a model will throw an error, I mean that is not practically possible. As you said, yeah, L1 ratio is 0.5 and L2 ratio is 0.6. So that is not practically possible. The sum has to be 1. So yeah, when it will start iterating, no, when it will come to that point, no, model will throw an error and model will stop working. So to avoid that, we just want to skip that part, okay, and let it run the model, okay. To do that, we set that values, okay. So yeah, so the 4.4, yeah, question, the assignment, yeah, okay, sorry. So this is the code, as I said, yeah, a length of data, how much is the length of target web, and what is the length of feature names. Okay, so it says like simply we have 8 features and to 20,640 number of samples. Okay, so what would be the dimension? It's simply like a number of samples into number of features. Okay, so yeah, what will be the output of the following code? It's a completely different. It completely depends on the code only. I mean, it completely depends on the California housing data set only. Okay, so it is like a list. What he is saying that it is you are asking for all the features names. So it will give you the all the value, all the name of features. Okay, a list of all the feature names. Okay, so yeah, these are the easy questions only. So yeah, which of the following feature has long tail distribution? So yeah, it completely depends on the data set. I mean, if you would have gone through the data set, then you would be able to see. Okay.
So will such questions come in the quiz one?
No, never. It won't come. There are no chances. I mean, yeah, it may happen like we are giving you the photos of 3-4 features. Okay, and yeah, here I can ask like which left is skewed, right is skewed, something like that. That we can ask. Obviously, we don't want to memorize you. Just but yeah, obviously somehow you can expect a few questions related to APIs. So yeah, yeah. Usually we try to avoid that, but yeah, there you can expect 1 or 2 questions may come related to APIs. Okay. In the video, why made house well has a spike at the end of its So it completely depends on the data set only. So yeah, how many missing values are there in the California? Yeah, this also depends on the data set. Okay, so I think, yeah, this is the last one, or any, yeah, 4.5 also we have. Okay, which module of sklearn contains the lasso API? So yeah, it all is in the sklearn.linear model. Okay, which of the following will return the California housing as a tuple? It is, again, no need to remember this type of codes. Okay, it's just like fetching up in data set, that it's not required. Okay, but yeah, to use that. And one more question I would like to ask, like, how many of you have written till now, like, each and every code by yourself, each and every line of code? You can mention in the chat box. Yeah, okay, just, yeah, because when you mention in the chat box, I will be able to see your names also. So yeah, Bhupesh, I think, yeah, Venu Madhav. So when you haven't used, you haven't typed any code, I would say definitely whoever hasn't typed any code, no, I mean, he will be going to struggle a lot in the OP exams, because for each and every step you have to search, and yeah, it will be highly time consuming, and yeah, based on that time pressure, no, it would be very difficult. I would say, I can say that only. I would definitely say just go through each and every line of code, because when you will go through each and every line of code, no, it's not, I mean, everyone just sees the code, no, like, yeah, we are able to understand, this one will work, this one, that one will work. But when you will start typing, no, then you will able to understand, like, yeah, this was also parameter. Here we can't set this one. I mean, yeah, polynomial P was capital. So when you will start typing, no, that. So in the OP exam, no, you won't know, like, polynomial feature has P capital, print has P capital or small, something like that. So I will highly advise you guys to type the codes, okay, by each and every line of codes. So let me see why.
The OP exam would be on our portal.
OP exam, I think last time we simply asked them to do on the collab only. So yeah, this time also we are not going to change that.
So it will be on the collab, is it?
Yeah, yeah, we can use.
So you're not audible.
Yeah, hello. Yeah, actually, I
Yeah.
was just fitting the charges. Okay, so yeah, this time also you can expect a OP exam on the portal only. Okay, maybe next time we may go to some other portal, something like that. But yeah, this time we will, you will build some. Yeah, obviously you will need. I mean, when you will be considering the time, no, whoever is a practice, no, of typing, no, they will be able to do that work. Okay, but otherwise, like, as I told you, no, in the last time also I saw people, like, were 20 to 30 questions. Okay, 30 questions, but those were easy one only. I mean, just a MCQ we are converting, like, how many tablet design. I mean, within 2 to 3 line of code, you will be able to answer 3-4 questions. But the thing was, no, I mean, that can be solved in, if anyone has practice of code, no, like, they can solve in 30 minutes. But many people felt it like lengthy. Why? It was just because you have to know. I mean, that person is, let's say, you type any terms, any parameter whose P was capital, and you type that is small. Okay, you will get the error, and now again you have to fix that error. So it will happen something like that. So it's always good, I would say, like, at least once you just type all the codes. It doesn't matter, just copy the codes. I mean, whatever is written, just simply type. Because yeah, as Sanjeev said, yeah, we build a muscle memory also. Okay, yeah, you have to build that.
Sir, I have one doubt. In when sir is coding, when he's fetching the data from a website or anywhere, sklearn library, he sets the random state to a certain number, and then in between also he sets random states when he's splitting the data or some other steps also. So why do you have to set random states at multiple times?
Yeah, you can set once also. I mean, it's just that, like, what happens, you know, like, we have, let's see, like, we typed some code, okay, for the first time. Okay, then again for this other model, I'm not going to type that code again. No, I'll just simply that copy paste that code. It is like that. So you can set a random state once on.
So at the beginning of the code, if we set random state, is that enough, sir?
Yeah, but in OPE exam, I would say like many people mentions that. Yeah, I mean in other questions also like they would mention like yeah, set here random state equals to 10 or 20, something like that. Then if it is mentioned in the question, then set that at that place also, I would say.
Okay.
Okay.
Okay, sir.
Yeah, and yeah, people will yeah, in the question it will be mentioned. That's for sure, because we don't want some random answers. I mean,
So if they've mentioned where to set the random state, we set the random state only at that place, right, sir?
yeah, that's true.
Okay.
Yeah, please do that. Okay, what will be the following? What will the following code implement? Yeah, so again, first and second question will belongs to the data set only. Okay, then the third question, so which what will the following code implement? Polynomial regression degree 2 is we are taking alpha equals to 0.1. I think similar question was there around, I think yeah, around in 4.2 activity question. Okay, what we'll do there, we had said degree equals 3. So what will do what will it do? No, I mean it simply transform the features of degree 2 and then it will perform regression with regularization rate equals 0.5. Okay, so yes, third one is correct. So fourth one, yeah, can anyone explain this graph? I mean, obviously, what would be the answer? First question would be that. So following chart plots MAE against degree of polynomial features for regression task on California housing data set. Okay, what is the optimal value of degree? Okay, can anyone explain? I mean, first answer the question. I mean, first answer the questions.
Okay. So overfitting, basically training error is reducing and but test error is increasing. So it's not able to evaluate or predict basically the data for test data, like the target value for test data. But
Yeah.
it is able to predict the values, all the values for training.
Yeah, that's correct. I mean, whatever you said, that is perfectly correct, and I understand that you are getting you have got the point. But yeah, someone just try to say in a proper manner, I would say that. I mean, so whatever you told, I know that yeah, that is perfectly correct, and no, that is the only the correct answer. But yeah, beyond 2 is overfitting, below 2 is underfitting. Yeah, that is also a perfect one. I mean, it's just that it when you said it in a concise manner, that's it. Okay, but yeah, whatever you said, no, that is also, I mean, yeah, same thing you told. Yeah, so we are seeing here like after 2, yeah, training error is decreasing, but the test error is continuously increasing. So obviously it is the case of overfitting. Okay, so yeah, so we should take the optimum value, that is 2. Okay, where training and test error is also both are minimum. Yeah, that's all. I mean activity questions. Then let's go to the practice question.
Shouldn't we take the point where both the errors are same?
Both errors are same. You can take that one, but at least at the end you have to take the minimum error. No, you have to take that polynomial degree where your error is minimum for both. It should be something like that.
Okay.
Yeah. Because at the end you want minimum error, so then only your model will be much more accurate. Okay, so yeah, the practice questions are quite easy. I mean, the first question says that explained variance score. Okay, compute explained variance score. That is simply, it is just I mean, you have to write some code in MLT, but here it's just like we have direct in SQL matrices, we have directly explained variance score. So just import that and yeah, use that to predict the model value. Okay, predict the score, I would say. Yeah. So first question is just a simple line of code. I mean, just first you define this as a function. Okay. And then yeah, again you just use this function to calculate the score. Okay. The second question, write a function compute the score extend x y turn x y to compute the score of SGD research for predicting the house price of California. Write your code. It is nothing but just simple code. I mean, you have to simply just import the California housing data set just split that, and then you use a standard scaler, and yeah, then you have to set the loss as a squared error. So yeah, one more question I got here. Okay, so here they have seen like loss as a squared error. Okay, penalty is L1 alpha is conjugate random distribution. Okay, so I think yeah, most of you, yeah, I'm assuming like all of you would have able to do this question. Okay, so I just observed one thing. I'll ask you guys. Okay, so in the first term, what it does is like it simply splitted the data set. It imported the data set and it splitted the data set. Okay. Okay. In the second one, what is done is no, it simply import the data set and yeah, it just transformed it using the standard scale. Okay. The main thing you here you see that we have set loss as a squared error. Are you able to see this one?
Yes.
And
Yeah.
is anyone of you remember like what sir has used in as a loss function? Anyone? Do you remember like what sir has considered as a loss function in their lecture before lectures?
Can you repeat the question, sir?
So I'm saying here in this question, I mean, they have trained using loss squared error, a loss edge squared error that is mentioned in the question also. Okay, so that's not, yeah, sorry, loss edge squared error. Okay, and so here they have used in the. I'm asking that in the sir's lectures, so what loss sir has used in that collab, whatever is used in the class. I mean, before lectures.
It was squared error only, I guess.
Mean squared error, I think.
Negative mean squared error it was. Do you remember?
Yeah, it was mean squared error, something like that.
It was.
Sir, there are only two losses for SGD regressor. One is squared error and other is Huber.
Yes.
Okay. So I'll just see the codes.
If you add NEG to it, it becomes score rather than loss.
Yeah, that's true. That should be this problem. Yeah, I just yeah, that's true. That's true. Whatever you said, that's true. I mean, yeah, that was a score actually. Yeah, I just got confused. I mean, yeah, that was a score actually. Yeah. Okay. Hoover loss and that was the okay. So one thing I would like to say. So yeah, is in the scoring, you have seen that sir has used negative mean square error. So can someone say why sir is negative mean square error? But actually in my mind it was the question. So I thought like that. Okay. Yes. Can someone say like why sir has used negative mean square error? I mean we would have used the squared error, no mean squared error or squared error, something like that.
So yeah, basically there are two concepts. One is error, the other is score. So error is a negative concept, like the values will be lower or negative. And if you want to check the score, you take the minus of error. That is what it was told in the one of the lectures. So score is a negative of error.
So why did we don't take like R square? We should also take that negative R square, something like that, according to your definition.
Yeah, it's like that only.
Yeah, that is what I'm saying. Here the thing is no. This one is visible. Yeah, this one. Okay. Let me show that. So what happens now in the score function? Like it behaves like more is the value, no, more better it is. More better the model is. Score function in SGD regressor, things like that. Okay. So more is the value, more better. Yeah, more is the score value, more better that model is. Okay. So if you set the mean square error, no, score equals mean square error. So what will happen is it will give you the score value. I mean, it will give you the model with the highest square error value. Okay. To avoid that, we use that negative mean square. So what we use is here. Let's say we have error as a 50. Okay, and error is 40. I mean total mean square error. Okay. So which one model one? Okay. Let's write is M1 and let's write is M2. Okay. So model 1 has a mean square error value as 50, okay, and model 2 has a mean square error value as 40. So which one will you choose? Which one is better model? I would say
M2.
M2 is a better model. Okay, yeah, that's true, because obviously it is giving you the least amount of least is mean square error value. Okay,
Right.
so, but what will happen in the in SGD regression? No, you when you will set the score equals mean square error. So what it assumes, no, higher the value, more better the model is. So it will take that it will give you the answer as a M1 is your best model. Okay, so to avoid that, we use that negative mean square. Okay, negative mean square. But in other cases, like other matrices, like R square, okay, and all other matrices, no. What happens is like the higher the score, better the model is. I mean, if your R square value is 0.6 and R square value is 0.5, then obviously R square value equals 0.6 is your this model will be better model. M1. So in that case, we don't have to worry about this negative sign. But what happens here is we just put the negative values. Okay, now minus 50, minus 40. So which one is greater value?
Obviously minus 40.
So yeah, minus 40 is better, greater value, and yeah, so this one will give you the then a ZD regressor will give you the M2 as a better model. Okay, and that is what we wanted.
Okay.
So yeah, to do that, we use that negative sign. Yeah, that is the one I wanted to cover. So last term here people.
Sir, this is for all error functions, right?
Not all error functions. In SGD regressor, it considers like that when you set the score. Okay.
Okay. So for like mean squared error is there, mean absolute error is there. So
yeah, you can set negative,
all,
mean absolute,
negative for all of them, right?
Yeah. Square error, if you are judging based on that, no, then yeah, definitely set that negative. Okay.
Yeah.
Yeah, that is one. And so have you observed some assumption which is considered in linear regression? Have you read about the assumption? Hello.
You are audible, sir.
Yeah, so I'm saying, yeah, have you read about any assumption in linear regression? Yeah, anyone? There are few assumptions in linear regression. Okay. So yeah, or just take it. Okay, when we say yeah, no. Okay, but yeah, just think like what should be the case. Then only you will use a linear regression algorithm. Or when you think like a linear regression algorithm won't work. Yeah, just I'm just changing the question. I'm just modifying the question. Answer would be same for both. Like what are the things you think that is needed to use the linear regression algorithm? Or yeah, in which cases you will use linear regression algorithm, and in which cases you won't use linear regression algorithm? I'm asking that. Okay.
If the points are scattered all over the place, then in that case, we might not be able to use linear regression. Right?
Yeah, that is the one. That is the correct one. Yeah, this one is correct. Okay, and yeah, I'll just try to modify this one. I mean, whatever you said, that is the correct. So this blank screen is a whiteboard is visible, no?
Yes.
Yeah, one is correct. Okay. So just think like before, what are the steps you do in pre-processing? Just think about that. You will get the answers. I mean, Yeah, anyone, any points you think? Just try to anything. I mean, just be it wrong or right. That's a different thing. But yeah, just try to say. You would have seen. I mean, whatever that I will tell you would have seen those things, and you will try to eliminate those things in your pre-processing step. Okay. So first point is, yeah, that's true. I mean, if let's say this one is your x, I would say, yeah, these are the points. I would say, yeah, let's say okay, this is your feature 1, this is your feature 2, and you have to predict that using linear regression. So obviously single line can't fit that line, these things, no. So obviously here you won't perform good, so you won't use whatever he said, like, yeah, the relationship between x and y and the mean should be linear. Okay, this is the one assumption. Okay, we assume that, yeah, relation between x and y, I mean dependent variable and independent variable, linear. Okay, that's the one thing. Any other thing? Any other? The second assumption you usually see, no, like you check, no, like, is there any duplicate data in your data set? Hello.
Yes.
Yeah. So why you check that? My question would be that. So why you try to avoid that? I mean, duplicate data. You want to remove the duplicated data. Features are independent. Yeah, that's correct. I mean, yeah, that is what I'm discussing correctly. Yeah, features are independent. Okay. Okay, features are independent. Yeah, so you are talking about the features. Yeah, that is also correct. We try to just, yeah, see the correlation. We remove the higher correlated features. So yeah, when you have the duplicate data, so necessarily it will increase the your calculation time. Okay, let's say you have 10 data set, 10 points only, and the same point is repeated like 1,000 times. So unnecessarily, why to see all the 1,000 points? I mean, you have to check that all the 10 unique points. No, are you guys getting my point, or I'm saying something alien?
Getting it.
Getting
Yeah.
it, sir.
Yeah. That is the one case, and second case is like features are independent. Yeah, that is also one case, because see, let's say you have two features. Okay, one is summer, one is ice cream. Okay, and you have to predict the temperature. uh, Maybe here we can set the categorical variable or something like, yeah, finally just see things like we have to predict the ice cream sale. It depends on summer. Then again, the temperature, I would say that is a bit good. Okay, temperature or any other some features. Okay, there can be like a price, something like ice cream price, or some other features. Okay, xyz. I'm not able to recollect one good example. Okay, but still I try to collect that. So what I want to say, I'll say that. Okay, so the thing is, like, here you have to predict the ice cream selling. I mean, it is how many ice cream sold. Okay, something like that you want to predict. Okay, so what will happen is, here, let's say we have two things. I mean, here we are mentioning the temperature in degree Celsius. Yeah, that's here we have mentioned the temperature in degree Fahrenheit. Here we are mentioning temperature in degree Celsius. I have both the things, okay, in our data set. So both things will give the same information only. So both things are ultimately giving the same information, or you can say these two features are highly correlated. Okay, so if you will use this one without removing these two features, I mean one of these two features. Okay, what will happen? No, it will the final equation. What will be made? No, let's say ice cream equals y, and this one is x1, x2, x3. Okay, so let's see, like 0.2 x1 plus 0.3 x2 and 4 0.4 x3. Okay, your model is something like that. So what is happening? No, you are giving very high weightage to this. I mean, you are giving very high weightage to temperature. Although we know that yeah, it is highly dependent on the temperature. But see, you can't say. I mean, if unnecessarily we are giving high weightage to these features. I mean, ultimately x2 and x3 are same. So it is something like this, 0.x1 plus 0.7 x2. It is something like that, no? So unnecessarily you are giving very high weightage to this one. So your model won't perform very well with the test data sets. Did you guys got my point or something else I should? Yeah, collinearity.
Yes, sir. This is something with related with collinearity.
Yeah. That's true. I mean, you can you would not have used that VIF factor, okay, variance inflation factor and all, okay. So where we just try to remove the highly correlated features due to this only, because ultimately that features will get high, I would say high weightage, okay. I mean, your answer for your model, I would say your dependent variable will be highly dependent on this one, these features, these independent features. Okay, so yeah, to avoid that, we just remove highly correlated features. Okay, we will remove this one, then it will get the weightage around 0.3 only or 0.4 only. So here currently its weightage around 0.7, something like that. I just assume that yeah, both the things are same, and actually the things are same. So we'll see these kind of problems. So these are the initial assumptions only. I mean, if these are the cases, your linear regression won't perform well. Okay.
So how we identify like such relations?
We have methods. I mean, first is obviously you can set that you can check that correlation factor. You have checked heat map.
Yes, sir. This we can perform in the Excel also. Means
that's true.
Matrix will come and all the all diagonal elements.
Yeah. So just try to see use this one SNS dot heat map. Okay. Seaborn, you import the seaborn and use that heat map. Okay. It will simply plot. It will create the box, and yeah, it will show you the all the combinations. I mean, how much related to one feature is related to the other features. Okay. One method is this one, and second method is VIF. Okay. Usually, what we do is like after training the model, we calculate the VIF for all the, and whatever whenever the VIF is greater than 5, we try to avoid that. Okay. Avoid that particular feature. Okay. Something like that. And we do that one by one. Okay. So this heat map is really useful. And third thing I would say, like you can think like third thing is like based on your knowledge of that domain. Okay. Let's see about the car. Okay. So I am saying a car has let's say car's mileage is something like that 70k. Okay. Somewhere around 70. Okay. And then I'm saying just any other features which is equivalent to which can if the car's mileage is 70, then obviously its engine size would be higher. No? I mean, engine size will be larger. I mean, the engine width, I mean, engine dia. Okay. Dia of this engine. Okay. I would sorry, dia of the cylinder. Okay. That would be larger. And also the length of this bore length, that would be also higher. So these things are ultimately correlated because more, not mileage, I would say, I mean, you can say speed or mileage will be lower actually. Higher the length and dia of this cylinder, the mileage will be lower. Okay, because obviously speed will increase. Okay, and power will increase if size of your engine is higher. So this thing comes from the domain knowledge. So you can understand, why we need both the things. Okay. So feature selection is a different thing. I mean, I'm talking about that also. So I can say before meeting in the next session, I would like to hear from you guys, like what are the assumptions in linear regression. I can just naming currently linearity, homoscedasticity, independence, and normality. These 4 assumptions are there. Any one of you can explain in the next session about this. Okay. I'm stopping sharing this one. Okay.
And yeah, anything else? I think whatever I wanted to cover, I covered that. And yeah, next week I'll take. The next session will be bit longer. Since in this session, yeah, we had very less content in activity part. In practice questions also, we just had 2 questions only. That too is with very lesser difficulty. So yeah, anyone
Just
having
one
any doubt?
general question related to labels. It was mentioned that labels are floating point numbers, right? So why
Labels
can't
are-
they be categorical?
Labels can be categorical, no? But the thing is, that's a logistic regression. In linear regression, it should be numbers. I mean, yeah. In logistic regression, it can be label. It can be. That is what you are asking, no?
Yes.
Yeah.
Okay.
For
So in
that, we have
in
other
label-
algorithm.
Okay.
Like
okay.
yeah. I mean, just to predict the color of the box,
Right.
red, orange, white. Yeah.
Right.
Yeah.
Sir,
Anything
can
else?
you go back to that equation that you had formed? Sorry, the whiteboard equation that you had written.
Yeah. Okay. Yeah.
I wanted to ask, if we remove features, you are saying that the weight for the other feature is more. The second equation that you have written.
It is completely. It doesn't happen actually like this. It is something like I have just for sake of example, what I did here is I just mentioned temperature in Fahrenheit, temperature in degree Celsius. So both the things are same, no? So basically, ultimately, we are defining same thing. Here also, I have represented it in x2 and x3, and we are giving some weightage 0.3 to this one, 0.4 to this one. After training of the model, we got the weightage this one and this one. So ultimately, it's the same thing, no? So that is what I see here.
Okay.
It's just a representation, nothing.
Okay.
It doesn't happen like the x2 x3 mix that.
Yeah, I got it. Okay.
Yeah.
Thank you.
Thanks. Yeah, tools of advice I will do. I will definitely give. Start practicing questions and start typing codes, because that will definitely help, especially in OPE exams. Otherwise, the same question, same thing will come. And mostly I am assuming that due to like last time, many people were saying that paper is lengthy, and at the same time, people were saying that 3 hours is too much. So I'm assuming that yeah, time will be decreased, and if they will decrease the time, no, then obviously the people who has just seen the code, they will have to struggle a lot. So yeah, that is also the case. And don't worry about the code. I mean, I understand like whoever is seeing the scalar for the first time, first 4 weeks, he will definitely feel that it's too heavy. But after this, I mean, the things you will see that all the things are same only. I mean, you have to just see few changes only. I mean, let's see.
Sir, we will be allowed to check the intelligence of the Google Colab. So when we click control space, we will get the hints, suggestions.
Yeah, you can use that. Whatever you want to use, you can use in the collab. No one is stopping you to use collab, and that is what I told you. If you can learn about that also. I mean, how to efficiently use that collab. I mean, how you can search for how can you can search for help and all.
During exam, he's asking during exam. We will
that is also not an issue. I mean, the exam also you can search like for help for pipeline and all. Yeah, whatever you want to do, just you do in this collab only. No one is going to stop you. Okay.
What do you use? Control plus V, is it?
Space.
No, control.
Control plus space. Okay. Yeah. And it suggests you the library. Okay. Okay. Thank you.
Also, I would suggest, just see, like there are many methods. I mean, I've also seen like when I was taking the last time few of it manually, I saw there are few methods. I mean, in OPE, so in collab, like where you can for the, let's say you don't know the exact spelling of the database at all, just search the sklearn.linear model. It will suggest you all the things. I mean, related to whatever the models we have in linear model, it will suggest. So from there you can see that, like, let's say that the spelling of SGD research, we have SGD and R is capital, and all the things are in small. So these things you can see from there. But as I said, if you won't practice using by your hand, no, then for how much you can search? I mean, for each and every term you can't search. No, you will in exam you have pressure also. It's a pressurized environment, so that's why I'm suggesting. Yeah, tractor scalar dot matrix. Yeah, here you can see now all the matrices.
Yeah, sorry. Hello, you were not audible properly.
How to practice the code? That's what I'm asking.
How to practice the code? Just
You are telling me
simply
you
say, no. Yeah, I'm simply just saying that whatever it is written here, no, just don't try to copy paste. Okay, just try to type that. That's it, nothing else. Just simply just see in your front at your front, no, and just simply type that. Okay.
So that thing we are doing, that thing we are doing, we are just typing the whole code from the video through and through, word by word. But that doesn't fix in the mind, because when I try to do something else from scratch, it thing strikes my mind. So
I got you.
Or in that condition, what
In
should
that case, I would
wait?
In that case, I would suggest you to create a simple model. I mean, my screen is visible on this demo part. I mean, MP4, MLP week 4 linear regression demo. Okay. So then try to write the code in a very simple manner. I mean, very layman manner. No need to put all these things. I mean, here, just see, trend test split. Okay. Is dividing the codes into two parts and is putting feature label and state to 42. Don't mention. Okay. Just try to think like in a minimum line, minimum word of code. Okay. You try to build your code. Okay. Build your model. Okay. In that case, then after that, like what when you this in this one also, like it seems like very, I mean, complicated, something like that. So no need to write. Don't use pipeline first. Okay. First, simply use like in the first term, just like use standard scalar to scale the data, then use linear regression to use the linear regression. Okay. Then just simply check the predict the score of your model. Okay. That's it. No need to do this one and that one at the first step. Okay. That is what I'm saying. Not you should not. I'm not saying that you should not use this thing. I mean, first you just use that. Okay. And slowly you will get comfortable. If you are typing, that's very well and good. That is what I am suggesting. Actually, the people don't type. I mean, they see that, I understand this one is there, that one is there. Yeah. So everyone understand, but when you won't type, no, you have to struggle a lot. And like that only just,
I just want to suggest like what I was doing. So I typed first, and then I created the same sheet again without looking at the code. So myself only from scratch. So wherever I was forgetting, I was referring, but I was not looking and copying. So I created the same sheet again by typing again. So that helps you remember.
Yeah, that is also a good thing. I mean, more you practice, more you comfortable you will get. And
Sir, the code,
Please say.
Sir, the code that you are showing here on the screen, I had a doubt in this one actually. We are doing this line rec CV results on the trained features and labels, com trained features and com trained labels. How do we end up getting a mean absolute error for the test set from this particular data set? Because we have a separate data set, we've already split it into two, which is com trained features and test features.
Okay, nice.
To get a error, mean absolute error for this data set as a test set. I mean, how are we saying that it is a test set error?
What is happening here? No, let's say you have 100 points, 100 data points. Okay. So what you did here, like first you just save 20 as a test set and 80 as a train set. Okay.
Yeah.
So here you gave the 80 points. Okay. So here we have CV cross validated. Okay. So what it is doing is it is dividing it into 5 parts. So I mean 80 data points is divided into
5 folds.
5 folds. Okay.
Yeah.
So in the 5 folds, 4 folds is your train point, and the 5th fold is your test point. I mean your test set.
So does that mean, sir, within that trained data set itself, I'm again having some part as a test? Does that mean that?
Exactly.
Okay,
Yeah, exactly that.
Okay. So even now we are not yet touching the final test set that we have.
Yeah.
Okay.
That's why we use train set, evaluation set, and that last is the test set. Okay. So just take it train and
Fine,
train
sir.
and
Yeah.
train and validation set. Okay, train and
Yeah, yeah.
validation set. It is something like that. Okay, and
Yeah,
that is what
it gets confusing, the terminology. So can you clarify the terminology that we use for test data within the folds and test data outside the folds? So I think yeah, you mentioned like it is a validation set, or which one is
Yeah, yeah.
validation and which one is test?
So see, the first you divided your data set here. I mean, in this particular case, I'm saying first what you did, like you divided your data set in train. Actually, he has done so many things. So
So first he has divided the data set first into com train and
yeah,
test, and then the
okay.
com train he has divided into train and development or something like that.
Yeah, that's
Validation set.
Yeah, he has again he has divided already. He has already divided this in a validation set. Okay, so don't just I'm taking telling as a general purpose. Okay, so here he has since already he has divided the evaluation set. No, I mean, so no need to divide that. But in general, what we do here is like we simply divide the train and test set, and then we use this test set. We don't touch this test set. Okay, whenever we will use this train set, no. In this particular case, these answers are giving you that one. I mean, in the train set, you are getting making 20% as your validation set, and rest 80% as your train set. So did you got my point, or should I mention something? I mean, should I show using the pictures? Hello.
So does it still take it 20% as we've mentioned before, or the folds? I mean, based on that fold, it divides, is it? And one
Based on the
fold it
fold,
keeps
yeah.
for one fold
Yeah.
it keeps for tests.
Yeah, based on the fold, it divides.
So it does that k
That-
minus 1 thing, sir.
Yeah, exactly.
Okay.
By default, it is set to 5. Okay, so yeah, that's why I said. So yeah, whoever asked, are you able to understand that, or what? I should show using some figures and all. I mean, yeah. Yeah, hello. Anyone? Anyone?
So what was the question?
I'm asking like anyone, any question?
Okay, okay, sir.
Yeah.
Sir, I have a general question.
Yeah.
So sometimes when we have the in the linear regression, we say that the formula is y is equals to w transpose x. So and sometimes we have also noticed that we use most of the times we use y is equals to xw. So which one is used in which case? Can you please?
I'll tell you one thing. Okay. Yeah, 1 second. Just let me see. See. Actually, it completely depends on the matrix shape. Okay, how you have been making that matrix. Okay, let's say your W matrix is something like this. Okay, I mean n cross 1. Okay, and X matrix is something like 1 cross n. Okay, which usually happens. Okay, then in this case, what you will do? Will you do any transpose or something, or you will directly multiply W into X? Or what will you do? Ultimately, for Y, which shape you want? N cross 1 you want, right?
Yes.
So you have to just see like I mean, it completely depends how you have coded, how you have written the code for other lines. So based on that only your matrix shape will be there. Okay.
So if you will multiply directly W into X, okay, so it will give you the, I mean, n cross n. Okay, this is not perfect for you. I mean, which is not suitable for you. So here you want n cross 1. So which combination you will use? Yeah, I think it's not. So I wrote something. Yeah, there are some. I mean, yeah, based on these only. I mean, based on the shape of your matrix. No? This is a weight vector n cross 1, and your x is something nothing but just n cross n actually. The features, no. So whatever is the shape, no. At the end, I would tell you this only. I mean, you have to see. Don't focus on that part. I will tell you. Just you have to focus that ultimately you have to make W. You have to multiply W and X in such a manner that your Y should be in n cross 1 form. Okay. And you won't see this thing, this kind of doubt in MLP. It is mostly based on MLP where you are by your hand you are creating matrix and multiplying it.
Yes.
Okay. Yeah, that's true.
Okay.
Yeah, in all cases, I would say in MLF also you would have seen many times that when there were many questions like when we have to take transpose, when we do not have to take the transpose, and many times like the same case sir is taking transpose and sir is not taking transpose. So it completely depends on the previous part. I mean, how they have created this. I mean, this matrix, whether it's a vector form or another form. Okay. I mean, n cross 1 form or 1 cross n form.
Okay, sir.
Yeah. Any other question or something? I mean, one thing I would say, yeah, you guys have missed many things. I mean, even I was also not planning to come here for the fest, but yeah, it was really quite interactive and I got to know like many people personally. So Venu, I was expecting you also. Hello, are you there?
Yes, sir. I am.
Yeah. I was
I wanted to come, but I was too busy here.
yeah, because yeah, all the famous names. I mean, we have been working from since last two term. No, it's the third term.
Yes,
yeah,
sir.
Yeah, hope we will meet. Yeah, many people had come. I mean, yeah. Hope we will meet in the next term. I mean, yeah, next fest, something like that.
Yeah, sir. Whenever is next time, I'll try to make it.
Yeah, yeah. Someone was asking something.
Yeah. So are we going to get the pictures of the event?
Yeah, I think everyone will get. I'm expecting that. I mean, they are sharing a few pictures on that. No, I mean that IITM BSc portal. I mean, yeah, their pages. They have no Facebook pages, and yeah, they have Facebook page. They have LinkedIn pages, and also Insta pages. So Insta I don't use. So yeah, but on Facebook and LinkedIn I have seen they are continuously posting pictures. But that's like just a 0.1%, I would say. And it was like a highly interactive session where you would have got the chance to meet the professors also. I mean, I also like, even though I have studied from here only, like I have been studying, I had studied from here, but there were few professors whom I haven't met like in current courses. So yeah, like Ashish sir and all. So yeah. So those things were also there. Okay, anything else? Yeah, in the next session, I will try to write a, like we will take a data set and completely not Iris or this one. You would have also got bored using this data set. No, we'll bring some new data set and try to just, and we'll take it practically as a just like a machine learning problem. And we'll try to proceed like that only. Okay. So it's just like another algorithms. What happens, right? You just have to use different algorithms, but here we have just one algorithms in our arm. So yeah, we'll use that. I mean, linear regression. Okay. And in that only we will use SG regressor, lasso regressor. We will try to see like how much accuracy increases. I mean, yeah, something like that. Okay. Okay, guys. Anything else? So yeah, bye everyone. We'll meet.
Thank you, sir. Thank you.
Yeah, thanks. Thank you all. Thanks. Thank you all.
Thanks a lot.
Thanks.
Thanks, Vinu. Thank you.